All right. So we're talking about variation. We're going to talk about direct variation and inverse variation. We say something varies directly or something varies inversely. So let's talk about what direct variation really means. So if something varies directly or if something has direct variation, it just means as you're still frozen, sorry. As one variable increases, so does the other variable. As one variable increases, so does the other variable. And I thought that I made some copies of these. Maybe not. I'm going to make a copy of these really fast for you guys. So what do you think? So if that's direct variation, what do you think inverse variation means? As one variable increases, the other variable decreases. Write that down, please. Okay, so did everybody write that as one variable increases, the other one decreases? Okay, then I'm going to move on. So when we talk about y varies directly as x, k is the variable that we use for the direct variation or the inverse variation. K is the variable that we use. So the first thing I want you to do is I want you to look at y equals k times x. And if you were to try and get k all by itself, what would that look like? How would you do that? Yeah, you would divide both sides by x. So k equals y divided by x. That's when you use direct variation. This is important. So let's look at this first example. If I study for 2 hours, I earn 90%. Just think of that as an ordered pair. 2 hours, 90%. What am I going to earn if I study for 3 hours? What is my percentage going to be if I study for 3 hours? Well, the direct variation, they vary directly. The more you study, the better your score is, right? Just that's a proportion. Y over x, 90 over 2 equals y over x, y over 3. How do you solve a proportion? Do you guys remember doing this? What are we doing? What method is that? Yeah, we're using cross multiply. We're just going to solve using cross multiply. 2 times y is 2y. 3 times 90 is 270, divide both sides by 2, and I find out that y equals 135. Now, that's probably pretty unrealistic, but it's still the same idea. The more you study, okay? Let's look at an example of varies inversely, inverse variation. This means as one variable increases, the other variable decreases. Charlie, are you with us or what? Yeah? Okay. So I want you to look at the equation that represents inverse variation, and I just want you to solve for k. Let's get k all by itself. How am I going to do that? If I wanted to get k all by itself, what would I have to do? Yeah, multiply both sides by x. So k equals x times y is for inverse variation. So our example, the number of books in my backpack varies inversely as the size of each book. For example, if each book is 150 inches cubed, I can fit 4 books in my backpack. But if the size of the book decreases to 100 cubic inches, how many books can I fit in my backpack? So I said, well, for 150, that was my first ordered pair. And then I don't know how many books I can fit when the size is 100. Well, they vary directly, so that means they are inversely, so they're equal to each other. Y times x has to equal y times x, or x times y. Well, x times 100 is the same thing as what? 100x. I'm just going to write that a little bit more appropriately. And what is 4 times 150? Okay. How am I going to get x all by itself? How do I figure out how many books I can fit? Yeah, divide both sides by 100. So how many books can I fit when the books are only 100 cubic inches? 6. X equals 6. 6 books. So the key to this is just trying to figure out if it varies directly, meaning they both, as one increases, the other increases, or they vary indirectly or inversely. One increases, the other decreases. So let's look at our first example. Example number 1 says y varies directly with x. So the first thing I'm going to do is I'm going to write down what my proportion looks like. K is y over x. So first thing I'm going to do. So now I have 2 sets of ordered pairs. My first one is the set y is 10 when x is 5. Well, that's just 10 over 5. And it's going to be equal to, I'm setting it equal to, I don't know what y is. Do you see where it says find y? So I'm just going to use the variable y. I'm trying to find y when x is 7. TJ, open your eyes. Tap him. Hit him. Yeah. Bud, pick your head up. We're not napping. So how am I solving this? Do you have your notes out? TJ, do you even have your notes out? Okay. Cross multiply. 5 times y equals 10 times 7. So 5y equals 70. How do I solve that? Divide by 5. Y equals 14. And that makes sense because 5 times 2 is 10 and 7 times 2 is 14. Makes sense, right? Can we keep going? Okay. Example number 2 says y varies inversely. What does that mean? What does k equal? Well, x times y. Very good. So I have 3 and 6. So 3 times 6 equals I'm trying to find y when x is 9. 9 times y. So I have 3 times 6 equals 9 times y. Well, what is 3 times 6? So 18 equals 9y. Divide both sides by 9, and I find out that y equals 2. All right, example number 3. Y varies directly with x. So k, my variable for direct variation, is y over x. So my first set, 2.4, y is 2.4 when x is 3. 2.4 over 3 equals, I'm trying to find y when x is 1.2. Does this make sense what we're doing? I'm just setting up proportions, right? Making sure that I put y where the y goes and x where the x goes. If I'm trying to find y, I leave it as the variable y. Cross multiply. 3 times y is 3y. 2.4 times 1.2 is 2.88. Yeah, I think it's 2.88. Someone check that. Yeah, okay, cool. What do I do now? Divide by 3. So what do I find out? Y equals 0.96. Okay. Example number 4, inverse variation. What does that look like? Okay. Yeah, k equals x times y. So 5 times 2.5, that's my x and y, equals, I'm trying to find y when x is 3. 3 times y. So let's see, 5 times 2.5 is 7.5, right? So 7.5 equals 3y. Oh, 5 times 2.5 is not 7.5. That's 3 times 2.5. 5 times 7.5 is 12.5. Someone check that. I'm sure it is. Okay, thank you. So now what? Yeah, divide both sides by 3. So this one is a repeating decimal, 4.16 repeating. The 6 is what repeats. It's like 4.166666. Goes on forever. All right. So it says determine whether each situation is direct, inverse, or joint variation. We don't do joint variation. That's an honors math 2. So you can just cross that out. And there are 2 joint variation examples on here. So the number of oranges in a box varies as the size of each orange. So let's think about this. If the box is this big and the oranges are this size, I can fit 10 oranges in there. But the same size box, if the oranges are twice the size, so what happens as the box, like as the oranges get bigger, as the size of the orange gets bigger, what happens to the number I can fit in the box? It gets smaller. So what is that? Inverse. Very good. The distance that I run varies as my speed and the amount of time. This is two variables, speed and amount of time. That's joint variation. You guys don't have anything like that at all. Joint variation is one thing changes as two other things are in play, like something like this. Okay, we don't do that. All right, the number of hours that a painter spends painting your house versus varies as the number of painters. So if I have two painters, let's say it takes 6 hours. But if I have three painters, it's going to take more time or less time? Less time. So as the number of painters increase, the time that they spend painting inverse. It decreases. Yeah. The amount of my paycheck varies as the number of hours I work. Let's see. The more I work, the more money I make. More. What is that? Direct. Okay. The height of a child under the age of 10 varies as the child gets older. Because it's because of the age of 10 is like, because by then it just starts to kind of dwindle off. But let's see. From infancy to age 10, the older you get, what happens to your height? Yeah. Direct variation. And then the last one, the volume varies as the radius and the height change. That's joint. You don't have anything like that. Joint variation. Okay, so again, I'm going to cross off the joint variation formula because we're not using those. And really, I want you to rely heavily on, I just want you to think of it like this. If you always think of K and set it up as a proportion, you will be splendid. So we have 3 more examples. One of them is joint. So really 4 more examples and then 2 word problems. So determine if the equation represents direct variation. Remember that's K equals Y over X. That's your direct. K equals Y over X. Inverse, K equals X times Y. And joint variation, we're not doing that. So do you see where it says, and then name the constant? That means find K. Name the constant, find K. So example number 10. What kind of variation is that? It's inverse variation. And what does K equal? What is the constant of variation? Yeah, K is 40. If K equals X times Y, then X times Y and X times Y equals 40, then K is 40. Let's look at example number 11. What kind of variation is that? It's direct. What is the constant of variation? Just negative 0.6, yeah. Example number 12 is joint variation. We're not going to do that. What about example number 13? Yeah, if I were trying to get K, the constant, all by itself, how would I do that? Yeah, multiply both sides by B. This is inverse variation because it's in the form A times B equals 10. So the constant of variation is 10. Thoughts? Easy? So application problems. If you work 40 hours in a week and you make $800, how much will you make if you work 60 hours? Well, the more you work, the more you make. So this is direct variation. So my constant equals y over x. So if I work 40 hours, I make $800. That's my first x and y pair. If I work 60 hours, I make how much money? I don't know. That's my second x and y pair. So 800 over 40 equals y over 60. So solve it. What am I going to do next? Cross multiply. So 40 times y is 40y. 800 times 6 is 48,000. Divide both sides by 40. Divide both sides by 40. 4 will go into 48. 12 times, add 2 zeros. So if you work 60 hours, you make $1,200. Okay. The more you work, the more you make. Direct variation. Two people. Oh, go ahead. Yeah. Yeah. So here's, I try to like think about it like realistically, like that whole, the more you work, the more you make. So if two people are shoveling and it takes them 40 minutes, so 40 minutes with two workers, how long is it going to take with 3 workers? It should take less time. So as the number of workers increase, the time decreases. So this is going to be inverse, right? An inverse variation. Remember that the constant is x times y. So 40 times 2 equals 3 times x. Well, 40 times 2 is 80 equals 3x. So when I divide both sides by 3, what is 80 divided by 3? 26.6 repeating, right? Which, and this is in terms of minutes, so 26 minutes, and 2/3 of a minute is 40 seconds, right? So 3 people should get it done in 26 minutes and 40 seconds. You don't have to be that specific, but I did want you to know. Vanessa, are you awake? You with us? Okay, so if you guys look at the next page, it says insert, like basically insert homework here is what that means. Did whoever printed off your packet insert the homework there? No. Because, well, I don't know why. I had my head up with that. So your homework is a separate packet. It's made problematic. So I'm sorry that it's not in there, and I apologize that it's a separate packet. But it is what it is. So sorry. Yeah, this is your homework. All right, who's down in ALC that I need to send